We are going to start reviewing for our Unit 3 assessment, which for this we are going to also see questions from Unit 1 and 2. So we're basically going to review different topics that we have seen throughout the whole year of algebra. So let's look at question 1. A ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. So basically the ball is going to get thrown up, it's going to reach the highest point, and then it's going to come back to the ground. So it's saying that height is y. So this is our height over here. And then it's saying x seconds, x-axis over here, seconds. All right. Now the question says, for which interval is the ball's height always decreasing? Well, decreasing. Here we're increasing. Ooh, then starting right here we start going down. So what number is this? That number, I see they want us to use x values, which means I'm going to use my values that go this way. So that number would be 2.5. If we're in between 2 and 3, then we're 2.5. So I'm going to get rid of anything that doesn't have 2.5. Okay, and then when do we stop? Well, once we hit to the floor, the ball's done. That's in between 5 and 6, so that would be 5.5. Choice C. Nice job. All right, let's look at the next one. The performance record of an investment stock during 1 month is represented by the graph below. Which of the following statements best describes the stock's performance? A. The stock steadily decreased. Good. Reached its lowest and then increased? Okay, maybe. The stock increased, then decreased? No. The stock decreased, then increased? Yes. The stock increased and then decreased? No. Okay. It definitely decreased, and then it definitely increased. Now, question A is saying that it gradually decreased, but then rapidly increased. Question C is choice C is saying that it rapidly decreased and it rapidly increased. I like choice C better because they both look like they were being done at the same rate. The increasing and decreasing, it's the same looking shape, which means that they both had to be rapidly or they both had to be gradually. It's not like we've seen one go faster than the other one. So choice C. All right, question 3. A construction company uses the function f of p, where p is the number of people working on a project, to model the amount of money it spends to complete a project. Okay? A reasonable domain. Ooh, domain is our input. Here we are inputting c, and c is the number of people. So we're talking about people. Would be. Well, if I'm people, I have to be positive. So it's not going to be c, and it's not going to be d. A says positive real numbers. That can be any number in the world, fractions, decimals, all of those. Whereas positive integers would only be whole numbers. Well, if we're talking about people, then it needs to be whole numbers that don't have a fraction or a decimal. So choice B. All right, let's look at question 4. The daily cost of production in a factory is calculated using C of x equals 200 plus 16x, where x is the number of complete projects manufactured. Which set best defines the domain? Domain would be the number we put in, which here is x. X is the number of complete products manufactured. Well, if we completed them, they have to be a whole number. So it's not going to be real numbers, and it's not going to be rational numbers, because those could all have decimals. And now, if I'm talking about complete products manufactured, that would have to be positive. Whole numbers could be, integers could be negative and positive, so I don't like that. So my answer is definitely whole numbers, because whole numbers are only positive and they don't have decimals. So that's good to represent the products. All right, 5. If g of x equals that expression, find the value of g of negative 2. That just means that x equals negative 2. So if we had the more fancy calculator, we could just tell the calculator that x equals negative 2, and then we could type in the expression. Here I actually have to do it out and plug in the number myself, substitute it myself, which is what you can see me doing right here. And I'm just typing in my calculator because I don't want to do the math myself and by accidentally make a mistake. And my answer is negative 5. Question C. 6. If f of x equals the absolute value of x to the third minus 3, find f of negative 1, meaning that x equals negative 1, and we want to know what would be the answer right here. All right, I can't do absolute value on this calculator, but let me type in the inside of the expression. Remember, I substituted in negative 1 for x, and I end up getting absolute value negative 4. Remember, absolute value means how far is a number from 0, so how far is negative 4 from 0? It's 4 places away. All right, 7. The expression this plus this is equivalent to. Anytime you add variables or radicals, they need to be the same. But the number under the radical here is not the same, so let's simplify. We're going to simplify square root of 48 by thinking, what perfect squared number can go into 48? It would be 16. 16 times 3. Square root of 16 is 4. Leave square root of 3 alone. Plus square root of 27. Let's break that down into 9 and 3. Square root of 9 becomes 3. Leave square root of 3 alone. Then 4 plus 3 is 7. Leave square root of 3 alone. So our answer would be choice A. Let's look at number 8. What is the sum of this and this? Sum means to add, so I have to add these two. But I cannot add them until the radicands, the number under the radical, is the same. So square root of 18, the perfect square number that could go into that is 9. The square root of 9 is 3. Leave square root of 2 alone. Plus square root of 72. We could break that down into 36 and 2. Square root of 36 is 6. Leave square root of 2 alone. So I know I'm going to have square root of 2, and 3 plus 6 is 9. Answer choice D. All right, let's look at the next one. Which of the following represents a function? Remember, the definition of a function is that every input has exactly one output. So if I'm talking about a table, I can't have any of the x's repeat. Because look here, 2 repeats. 2 is going to negative 6, and it's going to positive 6, making this not a function. So I'm going to get rid of any of them that have choice 1 in it. Okay, let's look at the next one. For a set of ordered pairs to be a function, I need to make sure that none of the x's repeat. Here, none of them do, so this is a function. Every input would have exactly one output. So I need an answer that has 2 in it, which would be choice B. And remember, this is not a function because this crosses twice, and then we don't really know how to do this, but if you did graph this on the calculator, it would look like a straight diagonal line going up, which would pass the vertical line test. All right, let's look at number 10. 4 relations are shown below. State which are functions. All right, let's look at choice 1. Choice 1. If I draw a line right here, it would be a function. Right here, the only point that we count is a shaded circle. So right there, it would be a function. But right here, it would not be a function because, look, it's crossing 2 times. So why are they not function? 1 is not a function because 2 closed circles go through 1 vertical line. Good. All right. Let's look at choice 2. We have 1, 2, 3, 2, 1, not a function. Choice 2 is not a function because x values repeat, meaning those x's have more than one y. We don't need that extra sentence, but it just makes me sound better. Let me show you what I mean. The x value 1 has 2 as an x, but it also has negative 2 as a 1, as an output. So that cannot be a function because the input has more than one output. All right, 3 is a function. None of the x's repeat. And 4 is a function because if you were to graph that, if you were to go to graph in the calculator and type in x squared and look at the picture of it, it looks like this U, and that would pass the vertical line test. All right, let's look at the next question. Given the set of ordered pair, which value of x will result in the set not being a function of k? So right now we have 8. I only care about the first numbers, 3, 7, and k. For this to not be a function, one of the numbers here would have to repeat. I don't see an 8 here. I do see a 3. 3 would repeat, making it not a function. Because if you replace this with 3, then the input 3 would go to 6 and it would go to 4. So it would not be a function. Number 12. Given this set of ordered pairs, -2, a, 1, and 0. I like to write it out because it's easier for me to see. Which replacement of a makes this a function? So for it to be a function, we don't want any numbers to repeat. So I wouldn't choose -2, I wouldn't choose 1, and I wouldn't choose 0. But choosing 4 is a good idea because then every input is unique, meaning that every input has just one output. Question 13. Let f be a function such that 2x minus 4, I'm going to type this into my graphing part of my calculator, is defined on the domain. The word domain means x. What is the range? Meaning these are our x values. 2, 3, 4, 5, 6 are our x, and we want to know what are the y. So we could go to the table here, and look, what number do we get for 2? We get 0. So I need something that has 0 in it. So not this. And not this, because that would include every number, and our domain is not every number. Then 3 is 2, that's good. 4 is 4, 5 is 6, and 6 is 8, meaning we are answer choice B. We are not choice D because we do not go to infinity. The numbers actually do stop eventually. All right, 14. If the domain of the function f of x equals 2x squared minus 8 is -2, 3, and 5, meaning these are our x's. What are our y's? Let's go see. Let's type in the function 2x squared minus 8, enter. Then let's go to the table. At -2, we get 0, so we need something that has 0 in it. Okay. Then at 3, we get 10, answer choice B. And then at 5, we would get 42. All right. Question 15. The effect of pH on the action of a certain enzyme is shown on the accompanying graph. What is the domain of this function? Ooh, domain means x. So let me cross out anything that doesn't say x. Okay, let's see. Where does our graph start? The graph starts at 4 and it ends at 13, so it is choice D. It would only be choice C if we used every value of x greater than 0, but that's not true because once it hits 13, it's done. All right, let's look at this next question. This next question says, what is the domain of the function below? As soon as I see this word domain, I'm going to think about x. So I'm going to get rid of any answer choice that says y because domain means x. Now, I know that my x-axis is my left and right axis, so I'm going to look for the leftmost point, and then I'm going to look for the rightmost point. Well, to get to this leftmost point, I would have went left 1, making it -1, and this rightmost point is 6. So my answer is choice A. All right, let's look at question 17. Question 17 says, the cost of airing a commercial on television is modeled by the function C of n equals 110n plus 900, where n is the number of times the commercial is aired. N has to do with times the commercial is aired. Based on this model, which statement is true? A, the commercial costs $900 to produce and 110 each time is aired. All right, let's just break down the formula a little bit more. 110n, and we know n has to do with airing. So I want something that has to say something about 110 each time it's aired. B, the commercial costs $0 to produce. I don't think anything costs $0 to produce, so that's not going to be the answer. C, the commercial cost $1,010 to produce. That doesn't sound about right, because I can't add 110n to 900. They're not like terms, so I don't like that answer. And D, the commercial cost 110 to produce and 900 each time it's aired. Well, the 110 is next to the n, which the n means airing, so our choice would be answer A. Question B. Question 18, my bad. Brian's hockey team is purchasing jerseys. The company charges $250 for a one-time setup fee. $250 one time. If you charge $250 one time, that means 250 should not be multiplied by anything. Because if you're multiplying it by something, it's happening multiple times. And I don't like question B. Choice B. Choice B says 23x. Where is the 250 for the one time? Okay. And then it says $23 each printed jersey. Well, and X is our jersey, so I need 23 to be next to X, which is choice C. I don't like answer choice D because that's saying I would do 23 times 250. But 250 is only happening one time. So it's actually answer choice C. All right, 19. The graph of f of x is shown below. Which point can be used to find f of 2? Well, the number inside the parentheses is x, so this means x equals 2. To get to x equals 2, that means we go to the right 2, which would be choice A. All right, 20. This person claims that the graph below represents a function. State whether they are correct. Here, good, here, no good. Look, it crosses here, and it would cross here. So, this person is not correct because the vertical line at x equals 2 has 2 points, basically meaning that there's 2 y values. All right, if f of x equals that, then what is f of 1/2? Just meaning that x equals 1/2, and we are going to type that in. So I'll put my fraction. On the top, I have the square root of 2. Instead of x, I put 1/2 plus 3. On the bottom, I put 6. Instead of x, I put 1/2 minus 5. And we get -1 as an answer. All right, question 22. Consider the function f defined by this. What is the value of f of -1? Again, this means that x equals -1. So let's see, parentheses 1 minus -1, parentheses 5 minus 2, parentheses -1. And I get 14. 23, if c equals this, find the trinomial that represents f equaling and g equaling. All right, so c equals g. You have to put the whole set of g in parentheses. 3x squared plus 4 minus 3. Instead of f, we put in parentheses. 2x squared plus 6x minus 5. All right, there's no number in front of the first parentheses, so just rewrite it. But for the second one, we have to multiply that -3. -3 times 2x squared is -6x squared. -3 times 6x is -18x. And -3 times -5 is +15. And now let's put together our like terms. C equals 3x squared minus 6x squared is -3x squared. Then bring the -18x. 4 plus 15 is 19. And this is our final answer. 24 is a very similar question, so you might want to pause it and try it. C equals A. A is 2x squared plus 7x minus 10 squared, which means we write it twice. Minus x plus 5. All right. We haven't really learned how to do a 3 times a 3, but basically you would just make sure that you're multiplying that by each thing. All right. Let's look at 25. Jacob is working on his math homework. He decides the sum of the expression must be rational because it's a fraction. Is Jacob correct? Well, let's see. Let's set this in ourselves. 1/3 plus 6 square root of 5 over 7. Oh, I don't get a fraction. When added together, I get 2.249 ... which is not a fraction. So Jacob is not correct. This is irrational. Good. All right, 26. A teacher wrote the following sets of numbers on the board. Explain why a plus b is irrational, but b plus c is rational. A plus b is square root of 20 plus 2.5, which equals square root of 20 plus 2.5, 6.972 ... which is irrational because it is a decimal that doesn't end or repeat. Good. And now let's look at b plus c. B plus c is 2.5 plus, which is remember, it doesn't matter the order, 17.5, which is rational because decimal ends. Good job. All right, let's look at 27. Write a definition for the term function. Every input has exactly one output. C. Create an example of a non-function. All right, I'll make a mapping diagram that has numbers, a number that goes to more than one thing. 1 goes to 1, but now I'm going to have 2 going to 2 and 3. And then I'll have 3 going to 2. So, explain how I can make this function. 2 has 2 outputs. 2 and 3. So, to be a function, it can only go to 1. One number. All right, let's look at 28. The two relations shown below are not functions. Explain how you can change each relation so that they become a function. All right, relation 1. At x equals 4, to make this a function, it should only have one output. -5, -4, -2, -1, -4. Oh, there's a problem. The x value, -4, repeats. So to be a function, we need to get rid of the point -4, 0 or -4, 4. Good. Because then as long as -4 is only there once, that would mean that the input -4 only has one -4 output. Right now the input -4 has 0 and 4 coming out of it. All right, let's look at number 29. State the domain and range for the function below. Domain is x, which means left to right. Let's look at how much to the left this graph goes. This is my leftmost point, -3, which is an actual point, so I'll put a square bracket. And the rightmost point is 3. Range is my y values, which tell me how low the lowest this graph goes is -5, when an actual point, to how high does this graph go, which is 4. All right, let's look at 30. State the domain and range for this function. Domain, again, means left to right. The leftmost my graph goes is right here, but it is an arrow, which means negative infinity. And the rightmost it goes is right here, which again is an arrow, so that's positive infinity. And range, the lowest this graph goes is -3, which is an actual point. And the highest it goes is an arrow pointing to the sky, which is towards positive infinity. All right, let's look at the next question. Solve the given inequality and represent the solution using different representations. All right. First, let's get our x's to one side, so I'm going to subtract 6x. 3x minus 6x is -3x, plus 7x is less than or equal to -2, minus 7. I get -3x is less than or equal to -9. Divide by -3. Ooh, when you divide by a negative number, we have to flip our inequality symbol, and that is my final answer. I could graph it by putting -3. This will get a closed circle since it's equal to, and we go to the right. Another way to write this answer would be that we start at -3 with a square bracket since it's a closed circle, and we go towards infinity. Question 32. Let's add 4.5x to both sides. 8 plus 4.5 is 12.5x minus 36 is greater than 64. To get rid of minus 36, we add 36 to each side. We get 12.5x is greater than 100. Divide by 12.5. We do not need to flip our sign because it's not a negative number. 100 divided by 12.5 is 8. To graph it, we put 8. It's just a greater than symbol, so we put a open circle and we point towards the right. And now this would be 8. 8 gets a parenthesis because it's an open circle, and we're going towards infinity. Infinity always gets a parenthesis. All right, let's look at this word problem. 33. The senior class at Porridge High School is purchasing sports drinks and bottled water to sell at the school field day. At the local discount store, a case of sports drinks is $13.25. $13.25 for sports drinks. And they said let X represent sports drinks. So I'm going to put a sports drinks right next to it. Plus, bottled water is $4.75. And bottled water is Y. And it says the senior class has 120 to spend. Well, if they have 120 to spend and I want to write an inequality, they could spend equal to 120 or they could spend less than it. Okay. If it just told me to write an equation, then I could have put an equal sign. Now it says 8 cases of bottled water were bought. Ooh, bottled water is Y, so I'm going to replace Y with 8. And that's less than or equal to 120. So then 4.75 times 8 is 38. So let's subtract 38. We get 13.25x is less than or equal to 120 minus 38. 120 minus 38 is 82. Then divide by 13.25. 13.25 divided by, oh no, other way around. 82 divided by 13.25. We get 6.18 ... How many full cases of sports drinks can be bought? Well, a number smaller than 6.18 is 6. 6 cases of sports drink. All right, let's see the next one. 34. John is buying drinks for his basketball game at the local discount store. A case of drinks costs $14.79 and a case of bottled water $5.89. John has 150 to spend. All right. The sports drinks were $14.79, which they say to use X for that. plus bottle of water is 589, and they tell us to use y. And they want us to use an inequality, which means less than or greater than, to represent that he only had 150 to spend. It would be less than or equal to, since it could also be 150. All right, 10 cases of water were bought. All right, let's see what number this is. 589 times 10 is 50.9. Then subtract 58.9 to both sides. After buying the bottles of water, 4 sports drinks left over is 150 minus 58.9. We have 91.9 left over. Divided by the price of each case of sports water, divided by 14.79, and we get x is less than 6.159 ... Oh, I should have put less than or equal to, yes. And the full cases that can be bought are 6. 6 cases of drink. $35. The graph below represents the height of Sam's kite over a period of time. Explain what the zeros of the graph represent in context to the situation. Zeros mean this horizontal line right here. Explain what the zeros in the function represent in the height. It represents the start and end of the kite, which is when on ground. All right, B, state the time intervals in which the kite is increasing. It's increasing right here from 0 to 0.5. Then right here it starts increasing again from 1 to 2. Good. State the maximum height in feet that the kite reaches. It's right here, which is 60. 60 feet. Alright, that is no question you should be getting wrong. And let's look at this last. Oh, that's actually all. That wraps up our lesson on Units 1 through 3, getting us ready for the next exam.